Hello everyone, my name is Ankita Singh and welcome to the one-shot session of the chapter Polynomials. If you want to score the easiest 4 to 6 marks in your board exams, then this is the chapter, guys. And from going through the very basic definition of polynomials to covering all the different varieties of MCQ type questions, assertion reason questions, case study based questions, 2-marker questions, 3-marker questions that come in your board exam, we are going to cover it all today in this session. And I know that you guys need notes, you guys need practice questions for practicing and revision. So for that, you can go to the link in the description box below, which will take you to PW's app, and there you can enroll yourself in PW's free batch and get it all. And I hope guys you know what PW is. It is India's leading institute which provides you lectures and courses from India's best faculties at very affordable rates. So yes, with that, let's get started. Before seeing the topics of polynomials, let's ask ourselves how much marks can we score from this chapter. So, देखो बच्चा, polynomial chapters comes under algebra. Okay. Now, the total weightage of algebra in CBSE boards exams is 20 marks. 20 marks, guys. Okay. Now, there are 4 chapters in the topic algebra. What are they? First of all, we have polynomials, right? Then we have pair of linear equations. Okay. Then we have quadratic equations. And finally, we have arithmetic progression, that is AP. Now, the weightage of polynomials in CBSE board exams is 4 to 6 marks. Okay, 4 to 6 marks, guys. Let me write this again. 4 to 6 marks. Now, that seems very less, but believe me, these are the easiest marks that you can score. Okay, so polynomials is one of the easiest chapter in class 10th. So please make sure that you cover the few concepts that it has. Okay, so yes, with that, let's come to the topics that we are going to go through. So first of all, we are going to introduce ourselves to the concepts of polynomials, degree of a polynomial, then we'll come to value of polynomial and then zeros of a polynomial. Now, these 3 are the topics from which very few questions come, if any. Okay, you can get questions from zeros of polynomial, MCQ type questions, but apart from that, you don't get many questions from the other topics. Okay, now comes the most important topics of polynomial chapter, which is geometrical meaning of the zeros of the polynomial and relationship between zeros and coefficients of quadratic polynomial. Now, these 2 topics are the topics you have to prepare well because you'll for sure get questions from these 2 topics. Got it? Understood? So, yes, with that, let's first of all understand from very basic what is a polynomial. But before that, we'll go through algebraic expression. We'll see what an algebraic expression is. I know you have studied it in smaller grades, but I know you have forgotten also. So yes, what is an algebraic expression, everyone? An algebraic expression basically is an expression in which you have constants, you have variable, and they are all related together with operators. What are operators? Minus, plus, and so on. Right? For example, here x is a variable, 6 here is a constant, right? So, we have an algebraic expression. Another algebraic expression that we can write is 1 over y minus 6y. This again is an algebraic expression, right? Okay. Now, everyone, is this an algebraic expression? 4 or 5 or 1 or 50, 600. So, see, 4 in itself is a constant, but if you write it like this, 4 into any variable with the power 0, then this form here can be said as an algebraic expression, right? Okay, now let's come to the terms of algebraic expression because again, a lot of people get confused there. So what are the terms of algebraic expression? So see everyone, this 6x cube is a term of this algebraic expression. Negative 2x is a term. 1 is a term. So what are the terms here? 6x cube, negative 2x, comma 1, comma positive 1, sorry. So basically, all the parts that are related together with addition operator, they are all the terms of your algebraic expression. Got it? So please don't eat the negative sign. For example, if you did not understand, you can think about it like this. 6x cubed plus minus 2x plus 1. So what are the things that are related together with addition operator? We have 6x cubed, negative 2x and 1. So these are the terms. Got it? So for example, in 1 by y minus 6y, what are the terms, everyone? The terms would be 1 by y, comma, negative 6y. These are the two terms. Right? And here you only have one term, 4x raised to power 0. Okay, so these are the terms. Now let's talk about coefficient also. Okay, so again we are just revising basic stuff right now. Okay, so let's talk about coefficient of x cube here in the first algebraic expression. So what is the coefficient of x cube, everyone? Then you have to ask yourself, what are you multiplying with x cube? Okay, that would be the coefficient of x cube. So what are you multiplying with x cube? 6, right? So coefficient of x cube is 6. Similarly, if you are asked what is the coefficient of x in the first algebraic expression, so you will ask yourself, what is getting multiplied with x? The answer is negative 2, right? So coefficient of x is negative 2. So whatever is getting multiplied with the variable, that would be the coefficient of that variable. It's as simple as that. Got it? So yes, this is all about algebraic expression. Now let's come to the main topic. What is a polynomial? So देखो, polynomial is a special type of algebraic expression, guys, in which the power of the variables are all whole number, or you could say no variable is in denominator. Okay, let's see the algebraic expressions that we have written here. Let's start with the first one. 6x cubed minus 2x plus 1. So here, notice the power of each of the variables. Here the power of x is 3. Here the power of x is 1. Here you don't have any variable, right? So you can say that each of the powers here, they are all what? They are all whole numbers, right? So you can say that 6x cubed minus 2x plus 1 is an algebraic expression as well as a polynomial. So this here is a polynomial. Got it? But if you talk about 1 by y minus 6y, now I have told you, in a polynomial, no variable should be in denominator, or you could say that the power of the variable should not be, should be a whole number, right? So when I talk about 1 by y minus 6y, we can clearly see that here y is in denominator. Or you can rewrite it like this, y inverse minus 6y, right? So again, the power of y, guys, it is not a whole number. Negative 1 is not a whole number, right? I hope you people remember what whole numbers are. Whole numbers start from 0. So 0, 1, 2, 3, 4 and so on. These are your whole numbers in case you have forgotten, right? So here we can clearly see that the power of y is not a whole number. So this here though is an algebraic expression, but it is not a polynomial. Understood? Basic. Okay. So all you need to do to check whether the given algebraic expression is a polynomial or not is to check the powers of each of the variable. If the power are all whole number and no variable is in denominator, then you will say that okay, it's a polynomial. Okay, so that was the easy definition. Now let's come to the standard definition of polynomial, which you all should know. Okay, so an algebraic expression of the form a naught x raised to power 1, a1 x raised to power n minus 1 plus an minus 1 x plus an, where what are these a naught, a1 and a2, a3 till an minus 1 and an? What are these? These are all constants. Okay, see, they have written they are all constants, and since we are dealing with the world of real numbers, so these constants are specifically real numbers. Okay, so these things that are getting multiplied with your variable, they are all real numbers. Okay, now another thing, see, this entire thing is a polynomial or is the standard form of a polynomial in the variable x, right? and it has a degree n. What do you mean by degree? Okay, so we'll see degree's definition, but for now remember, degree is the highest power of the variable in the entire polynomial. Got it? For example, if I write 7x raised to power 4 minus 2x cube plus 3x plus 1. So here all the powers are whole number. So it's a polynomial. Now what is the highest power, everyone? You can all see that the highest power is 4, right? So we will say that this thing has degree 4. Degree is equals to 4. So highest power of the variable. Got it? So now they are saying that this entire thing that is written, it has a degree of n. Okay, that means the highest power of the variable is n. This n. This is the highest power of the variable. Got it? Now they have written that a0 cannot be equals to 0. Why can a0 be not equals to 0, everyone? So think about it. This entire thing is a polynomial with degree n. That means the highest power of the variable should be n, right? But if a0 becomes 0, then what will happen, everyone? Clearly a0 x raised to power n will become 0. Obviously, if a0 is 0, then 0 multiplied with anything is 0. So then the polynomial will become what? The polynomial will become a1 x n minus 1 plus a2 x n minus 2 plus dash 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 finally till an. Right, everyone? Now here in this polynomial, the highest power of the variable has become n minus 1. So this here is a polynomial of degree n minus 1. Right? So since we are specifically saying that this polynomial here has degree n, so we can't have the constant that is getting multiplied with x raised to power n as 0, because if that happens, then the degree would not be n. That's why the leading coefficient, what do you mean by leading coefficient? Leading coefficient is the coefficient of the variable with the highest power, right? So this leading coefficient, everyone, cannot be 0. Cannot be 0. Because we are specifically talking about a polynomial with degree n. That's why they have written this. Okay. So this is how you write a polynomial in standard form. Now, why is the standard form necessary? Why should you know this? We'll understand this. Okay. So let's understand this. But before that, let's talk about polynomials. Which of the following are polynomials? Okay. So yes, I hope you people will answer in the comment box. Treat it like your rough page, everyone, and give your answers there. Let's see. 5y minus x raised to power 24. Now, in this algebraic expression, you have two variables, y and x, right? But you do not need to get confused. Did I specifically say about, polynomials not having more than one type of variables? No, I did not, right? The only thing we mentioned was that the power of the variable should be whole number and no variable should be in denominator. Now, here you can see that both the powers here are whole number and no variable is in denominator. So, this here is a polynomial. This here is what? It's a polynomial, everyone. Okay. Now, let's move on to the second one. X raised to power 3 by 2 minus x root x. This is quite interesting. So, let's see, everyone. Now, x raised to power 3 by 2. What is it? What is it? So, you can write it like this. X 1 plus 1 by 2 minus x root x. Okay. Now, x raised to power 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. So, that's what I have done here. Okay. Now, notice how I can write this like this. X raised to power 1 into x raised to power 1 by 2 minus x root x. Whenever the powers are getting added, that means what is happening? You have two variables with the powers getting multiplied, right? So, I've just used laws of exponents here, nothing else. Okay, now x raised to power 1 is x only and x raised to power 1 by 2 is root x. So, x root x minus x root x. Now, that is equals to 0, everyone. Okay, so what I have written here is actually 0. So, in case some of you people might have said that, okay ma'am, the power of x here is clearly not a whole number and it's not a polynomial. You're wrong, guys. Why are you wrong? Because you needed to simplify this. Okay, simplification means that if there are like terms, you need to evaluate them together and hence bring the polynomial to its standard form. Remember the standard form that we studied, right? So remember, you have to always evaluate like terms first, simplify the polynomial into standard form, okay, and then you have to check whether the expression, not polynomial, sorry, whether the expression is a polynomial or not. So we have simplified this, we got 0. Now the question is 0 a polynomial? Yes, is 0 a polynomial, everyone? Okay, let's see. So see, as I told you about any constant, like if you have any constant, you can always write it as, any variable raised to power 0. Now for 0, we have a special case. We can write it as any variable raised to any power. Raised to any power, guys. Any power. Right, because 0 multiplied with anything is 0, right? So yes, we can write 0 multiplied with any variable with any power. So yes, 0 is a polynomial. 0 is a polynomial. In fact, it is such a special polynomial that it gets a special name. The special name is 0 polynomial. So, under 0 polynomial, you only have 0. So, 0 is like, in this category, only I rule, right? So, 0 is also a polynomial. Hence, this thing here, option number B here, is a polynomial. It's what? It's a polynomial. Okay, so I'll write it here. It's a polynomial. So, don't get confused. Always, simplify first and then answer. Now, next one, x over x squared minus 8x plus 7. Now, here you can clearly see that there are variables in denominator. And I told you that in polynomials, you cannot have variables in denominator, right? So, this is not a polynomial. This here, not a polynomial, everyone. Not a polynomial. Now, finally, y minus 1 by y. I think we have already discussed it. We have a variable in denominator. So, again, not a polynomial, guys. Okay. So, I think this was very simple, very interesting. With that, let's move on. Okay, now let's talk about degree, though we have already talked about it. But still, let's revise. What is the degree of a polynomial? Degree of a polynomial is the highest power of the variable. And obviously, for a polynomial, the degree will always be a whole number because all the powers of the variables are what? Whole number, right? With that, give me an answer for this. If I have x squared minus 2, then here we have x cube plus 1 plus x raised to power 4. This is my polynomial, everyone. And remember, we denote polynomial by small p, and then inside we have the variable that we are using. Here we are using the variable x, so I wrote x. If we were using the variable y, I would have written y, and so on, right? Okay, now what is the degree of this polynomial? What is the degree of this polynomial? Is it 4? Because, it seems like this is 2, this is 3, this is 4. So, 4 is the highest power here. So, 4 should be the degree. Or is it? See, everyone. Do you remember I told you about the importance of standard form of polynomial? Right? See, you always have to convert a polynomial into standard form and then determine the degree. And by converting into standard form means you should have individual terms that are related to each other by addition sign. Got it? Individual terms related to each other by addition sign, and no like terms, because all the like terms should be evaluated. Okay, now here we can clearly see that this is not in standard form. To convert it into standard form, everyone, what you'll do, you'll multiply and basically open up the bracket, right? So x square into x raised to power 3. So whenever you have the same base and you're multiplying, then the powers get added, right? Please remember laws of exponents. So 2 plus 3, everyone. I'm doing it in a very basic way so that you people understand. Then x raised to power 2 into 1. So x square. Minus 2 into x cube. So minus 2x cube. Minus 2 into 1. So minus 2 plus x raised to power 4. Right? So now this becomes x raised to power 5 plus x square minus 2x cube. Then minus 2 plus x raised to power 4. You don't have any like terms now, and now you can clearly see that this is actually the standard form here. Each of the terms are what? They are separate, right? They are all related to each other with addition sign. What are the terms? X raised to power 5, x square, minus 2x cube, minus 2, and x raised to power 4. Now, what is the highest power, everyone? The highest power clearly is 5. So, the degree is 5. Got it? Understood? This was very easy, but I know that a lot of people would have answered incorrectly if such type of question would have been asked in your exams. Right? So yes, please remember these basic details. With that, let's move on and talk about types of polynomials. So we are basically going to discuss types of polynomials based on degree and based on number of terms. So with that, let's start by talking about the types of polynomials based on number of terms. So if a polynomial in standard form has exactly one term, then it is what? It's a monomial. Let's write certain examples of monomial. We have 5y, or we could have minus 21y raised to power 6, or we can have simply 6. 6 is also a polynomial, right? Because it can be written as 6 into any variable raised to power 0. Right? So every constant is a polynomial. 0 is also a polynomial. We'll be discussing it again, so don't worry about it. But for now, these are your monomials. They only have one terms. Right? Next, we have binomial. Binomials are those polynomials that have exactly two terms, everyone. Let's write certain examples. Let's say you have 2x minus 4y, right? Or you have 6x cube minus 1. Or you have y square minus 2. These are all what? Binomials. Why? Because they have exactly two terms, guys. And that's why knowing what terms are is important. Can you see two terms in each of these? 2x and minus 4y. These are two terms. 6x cube and negative 1. Two terms. Y square and negative 2. Two terms. Right? Okay. Now, what is a trinomial, everyone? In a trinomial, you have exactly three terms. So you can have something like x minus y minus z, or you can have, x cube minus x square plus 1, or you could have, x square minus y plus 3, and so on and so forth. You can have so many examples, right? So yes, polynomials with three terms. Now, can a polynomial only have three terms? Obviously not. A polynomial can have any number of finite number of terms basically, right? But we are only discussing about monomial, binomial and trinomial right now. Okay. Now, again, I have a question for you. I hope this time you'll answer correctly. Okay. What if I give you a polynomial like this? 4x cube minus 2x cube plus 3 minus let me change this. I'll write this again. 3x cube, 3x cube minus 2x cube plus 3 minus x cube. Okay, this is my polynomial, everyone, and I want you people to tell me what type of polynomial is it. Is it a monomial, binomial, trinomial, or is it a polynomial with four terms? Yes, what do you think? We can see that there are four terms, right? So a lot of people would be like, ma'am, it has four terms, right? It's not a monomial, binomial or trinomial. But remember, I told you, whenever you are answering questions of degrees of whether, a polynomial is a monomial, binomial or trinomial and so on, then always you have to convert the polynomial into standard form and then answer. Got it? So this here is not in standard form. Why? Because there are like terms here and you have to evaluate like terms together. So no like term should remain. So what are the like terms, everyone? 3x cube minus 2x cube and minus x cube, right? So when you evaluate them together, 3x cube minus 2x cube minus x cube, these becomes 0. Right? So 0 plus 3. Px is equals to 0 plus 3, which is 3. So ultimately, this polynomial that I have given here is a monomial. It is what? It's a monomial. Understood? Evaluate like terms together. Convert it into standard form and then answer. So yes, I hope you understood this. With that, let's move on and discuss types of polynomials based on degree. Okay, let's start. So first of all, we'll be talking about 0, degree 0. So if the degree is 0, then the name of the polynomial is not 0, it is constant, everyone. Sorry for this mistake, it's constant. Basically, every constant polynomial has degree 0. And I think you can already tell why. For example, if I write, 7. So 7 can be written as 7x raised to power 0. Right? Or if I write, 100, 100 can be written as 100 into z raised to power 0, because anything raised to power 0 is 1. So 100 into 1, 100, right? So yes, all the constants which can be denoted like this, a, where a is not equals to 0. All the constants a, where a is not specifically equals to 0, come under constant polynomials, and their degree, everyone, is always 0. The highest power of the variable always is 0. Now, why did we not include 0 in this constant polynomial? What is wrong with 0? Why did 0 get its own category? Because guys, see, the problem with 0 is I can write 0 as 0 into x raised to power 0, but I can also write 0 as x raised to power 1. I can also write 0 as x raised to power 100. I can write 0 as 0 into x raised to power anything, because 0 into the variable with any power will always be 0. So 0 is like, I am not going to have any fixed degree, right? I can get multiplied with a variable with any power and I'll be myself. Right? So that's why we cannot include 0 into constant polynomials, because constant polynomials degree is fixed at 0. But for 0, the degree clearly is not fixed. Right? The degree keeps changing. So what do we say about the degree of a 0 polynomial? We say that it is not defined. It is what? It is not defined, everyone. Right? So 0 has its own category and you just write it like this, 0. Okay, now let's talk about a polynomial with degree 1. That means the highest power of the variable should be 1. So we call that a linear polynomial, which you have studied a lot. Right? You have studied how to find the solution of linear polynomials or zeros of linear polynomials. Okay, so linear polynomials can look like this. 2x plus 1. This here is a linear polynomial, right? Or you can write negative 4y. This also is a linear polynomial, because in both the scenarios, the highest power of the variable is what? 1. Right? So what is the standard form of a linear polynomial? You can say that the standard form is ax plus b. Where I'm talking in terms of x, you can write any variable basically. But here you specifically will have to mention that the leading coefficient a is not 0. Why? Because if a becomes 0, bacha, then this ax will not remain, only b will remain. Where b is what? It's a constant. So this becomes what? This becomes a constant polynomial. Because for b, the degree will be 0. Right? So a cannot be 0. B can be 0, guys. See here, b is 0. Right? But a cannot. Leading coefficient cannot be 0, right? Next, we have quadratic polynomials. So, quadratic polynomials are polynomials with degree 2, right? Some examples here. Let's write x square minus 1. What is the highest power of the variable? 2, right? Or we can have y square minus y. What is the highest power of the variable? 2. Or we can simply have z square. Highest power of the variable, 2. So what is the standard form, guys? Standard form is ax square plus bx plus c, where again the leading coefficient a cannot be 0, because again if a becomes 0, then this term will not live. Only bx plus c will remain, which is a linear polynomial, because the highest power of the variable is 1, right? So that's why you need to specify that the leading coefficient, that means the constant that is getting multiplied with square wala power of wala variable is not equals to 0. Right? Now, I hope you can write the standard form of a cubic polynomial. A cubic polynomial has degree 3 and its standard form is ax cube plus bx square plus cx plus d, where again leading coefficient a cannot be equals to 0. Everything else can be 0, guys. For example, in quadratic polynomial also, you can see that apart from a, anything can be 0. B can be 0, c can be 0, right? But a cannot be 0. Leading coefficient cannot be 0. Got it? So you can see some, you can write some examples for cubic polynomials also, x cube or x cube minus 2 and so on and so forth. Highest power should be 3. That's it. You do not have to be concerned about number of terms. Do not get confused with number of terms. Only see the degree. That's it. That's all that matters. Got it? So yes, these are certain types of polynomials based on degrees. So with that, let's move on and do this problem here. And it's a very easy problem. Let's see how many of you people can do it. You have to identify the cubic polynomial among all of these. Cubic polynomial, guys. Okay, so first of all, let's see the first one here. What is the problem with this first expression? The problem here is that this first expression is not even a polynomial because you have, you have a variable in denominator, and we have specifically said that in polynomial variable cannot be in denominator. So this here is not a polynomial. So you don't even have to check whether it's cubic or not. Okay, this is not a polynomial, everyone. Next, x raised to power minus 3x plus 2. Again, the power of the variable x is what? It's not a whole number, right? This negative 3 here is not a whole number. So again, what you will say? You will say that this again, not a polynomial. Not a polynomial. Right? Now, 5x cube, everyone. What is the highest power of the variable? 3. For cubic polynomial, what should be the highest power of the variable? 3, right? So yes, this here is a polynomial with highest power as 3. So yes, it's obviously a cubic polynomial, right? This obviously is cubic polynomial. So option number C is the correct answer. That's it. It's as simple as that, right? So I think this is pretty easy, pretty basic. With that, let's move on to value of a polynomial. So now we are done with introduction of the entire polynomial chapter. Very few questions are asked from that topic, but still it is very important that you know your basics, guys, because if even one MCQ is asked from there and you are not able to answer that, then that would be really, really sad, right? Because it's very easy, you know? So that's why always cover your basics and then move forward. Now let's talk about value of a polynomial, guys. What is the value of a polynomial? Value of polynomial px for any real number a is obtained after replacing x by a in px. Let's understand this using an example that will be easier. For example, if I write polynomial px as, let's say, 5x squared minus 2x plus 1. This is my polynomial, guys. Now I want the value of polynomial px at x is equals to 1. At x is equals to 1, I want the value of px. So what you have to do in such scenario, you have to do nothing. You have to take the same polynomial px, and in place of x, you are going to replace 1. Like you are going to write 1. You are going to replace x with 1, right? So this basically means you have to find p1. So in the polynomial px, replace x with 1. So what do you get, everyone? You'll get 5. In place of x, I'm writing 1. So 1 square minus 2 into 1 plus 1. What do you get? You get 5 minus 2 plus 1. That is 6 minus 2. That is equals to 4. So basically, when the value of x is 1, then the value of px is what? It is equals to 4. Do you know what that means? Geometrically, let's understand. So for example, I have a polynomials graph, right? So basically, px basically is denoted by y coordinates. Okay? And x obviously is denoted by x coordinate. So whenever x is 1, then the y coordinate would be 4. Y coordinate would be what? 4. Right? So whenever x is 1, y coordinate is 4. Right? I'll write it again here. You can write it like this: x, comma, px. And that's, people, how you basically plot the graph of any polynomial. Right? You take the values of x and put those values in px to find the value of px. And then you plot the entire thing. Got it? So yes, I think this was pretty simple, pretty basic, and you have a question of board exams here. It was asked in MCQ in 2023, right? Okay, so px is given as x squared plus 5x plus 6, and you have to figure out the value of p of minus of 2. So let's do it, everyone. We all know what to do. We will just replace x with what? Minus 2, right? So minus 2 squared plus 5 into minus 2 plus 6. Okay, minus 2 square is 4 everyone. 5 into minus 2 is minus of 10 plus 6. When you evaluate the entire thing, you get 0. So basically, option number B is the answer. And what does this mean? This means that as x becomes -2, the value of polynomial reduces to 0. Right? Okay, so I think this was pretty easy. Bilkul free ka marks, right? And everyone that gave the correct answer and you did it yourself, pat yourself on the back. Good job, guys. Well done. Okay, chalo. Now, let's talk about zeros of a polynomial. So, zeros of a polynomial basically is the value of x for which the polynomial px becomes 0. For example, here, let's look here. What happened? For x is equals to -2, px becomes 0. Yes, as I plug x is equals to -2 in px, the value of px became 0. So I will say that -2 is the zeros of the polynomial px. Right? So yes, the value of x for which px becomes 0 is the value is the 0 of the polynomial. Let's take some more examples, guys. Let's take a linear polynomial, 5x plus 3. Right? Now, what would be the 0 of this polynomial? The 0 of this polynomial would be the value of x for which px becomes 0. Now, there are different methods to find the zeros of the polynomial. One is hit and trial. In hit and trial, you will just think, what can I put in place of x to get this entire thing to be 0. So, there you will just have to try different values of x, right? Another method for linear polynomials. This is for linear polynomials. Okay? And you have studied this method a lot. For linear polynomial, what you will do is, you will start by putting px is equals to 0. Okay, so 5x plus 3 you will put as 0 and you will simply evaluate the value of x. Right? So what you'll do, you'll take everything on the right hand side and just leave x on the left hand side. Right? So x will come out to be -3/5. Now, you can check, okay, you can check. Let's put p, let's put x as -3/5 in the polynomials and see what we are getting, right? So, p of -3/5 would be what, everyone? 5 into -3/5 plus 3. 5 and 5 gets cancelled. We have -3 plus 3 and we have 0. See? So, we will say that -3/5 is the 0. This here is the 0 of the polynomial. Is the 0 of the polynomial. Okay? Simple, basic. I think linear polynomials, zeros are the easiest to find. Okay. Now, let's see how to find the zeros of a quadratic polynomial. Now, this is one type of questions that have been asked in your board exams. So, this is something that you should know. Even in quadratic equation chapter, you have questions where you have to find the roots of a quadratic equation. But the method is exactly same. So, be it finding the zeros of, quadratic polynomial or the roots of quadratic equation, both of these have the same method and questions are asked from these topics. Okay? So, please remember how to find the, how to basically find the zeros of a quadratic polynomial. With that, let's revise how to do that because you have studied it already in 9th grade. Hai na? Chalo. So, we have px x square minus 5x plus 6, right? So, I'll write it like this. X square minus 5x plus 6. Now, step number 1, everyone, is to put px as 0 because we have to find the value of x for which px becomes 0. So, we start by taking px equals to 0. Okay? So, that means what we'll get? We'll get x square minus 5x plus 6 is equals to 0, right? Now, what we are going to do is we are going to factorize the left hand side, okay? How do you factorize the left hand side? So, what do? You take the, variable with which has like power 1. For example, here x has power 1 and you see its coefficient. Its coefficient is what? -5, right? So, you will find two numbers which on adding gives -5. Now, remember, these numbers can be any real numbers, right? So, A and B basically on adding up should give you -5. A and B can be positive or negative, anything. Okay? Now, A into B should be equals to constant. A into B should be equals to constant. What is the constant? 6. Okay, so I'll write it here. A plus B should be equals to coefficient of X, and A into B should be equals to the constant. That's it. Okay, now what you will do first of all is you will determine the signs of A and B. Okay, that's the first step, everyone. You can see here that A into B is 6. So that simply means that either A and B are both positive, they are both positive, or A and B are both negative. They are both negative. These are the only two scenarios. Negative into negative is positive and positive into positive is positive, right? Okay, another thing, everyone, is A plus B is negative 5. Now, from here you can clearly say that if A plus B is equals to negative 5, then obviously A and B both cannot be positive, because if both of these are positive, then the result would be positive, right? So that means ye wala scenario too is cut, right? The only scenario left is A and B are both negative. They are both what? They are both negative. Got it? Okay? So now you are going to figure out two negative numbers whose product is 6 and whose addition gives you negative 5. So I think you can easily figure that out. Yeah, you can, first of all, you can start by the product. So you can see that negative 2 into negative 3 is 6. And negative 2 plus negative 3, everyone, is equals to negative 5. So you have figured out your two numbers, right? So what you are going to do basically is you are going to take this negative 5 and you are going to write it as negative 2 plus negative 3, right? So I am going to break down negative 5 as negative 2, negative 3. X plus 6 is equals to 0. So you have split the middle term. That's why this is called splitting the middle term method. You have taken negative 5x and you have broken it down as negative 2x, negative 3x. Right? What you have done? You have taken negative 5x and you have broken down it as negative 2x, negative 3x. That's it. Split the middle term. Now you will take, something common from the first two terms and something common from the last two terms, right? And you will ensure that whatever remains inside the bracket is same. For example, I take x common here, so I'll get x minus 2 here, right? Here in the last two terms, I'll take negative 3 common, so I'll get x here and here minus 2 is equals to 0. Right? Now we have two terms here, right? And in both the terms, what is common? X minus 2 is common. Can you see? So you will take x minus 2 common. So in the first term, only x will remain. In the second term, only negative 3 will remain. And this is equals to 0. Okay, now remember guys, if the product of two things is equals to 0, then there are two scenarios. Either A is equals to 0 or B is equals to 0. Obviously, common sense, right? So from here you can say that either x minus 2 is equals to 0 or x minus 3 is equals to 0. And from both of these, what you'll get? You'll get that either x is equals to 2 or x is equals to 3. So what are the zeros of the given polynomial? 2, 3. 2, 3. Everyone that gave the correct answer, pat yourself on the back, guys. Good job, well done. And I have, taught this entire splitting the middle term method from the very basics, so that if you have forgotten it, I hope you now remember it. Okay. Now, the main thing about splitting the middle term method is you need to practice as many questions as you can to become good at it. Okay. So, if you are confused, still confused, please make sure that you practice more questions. Okay. We'll also practice one more problem on the same method for you people, but you will still need to practice at least, 15-20 questions. Please do that, guys. You do have questions from this. Okay, in your board exams. Find the zeros of the polynomial px is equals to x square plus 4 by 3x minus 4 by 3. This is a question from 2025, CBSE board exams. So you can understand the importance of this, right? Okay, so let's start everyone. So what I'll do first of all is I'll see that, okay, before starting the method, I need to get rid of these denominators because they are really, really bothering me, right? So what I'll do is I will take px here, and I will, first of all, I will take the denominator 3, okay? So, I am going to make the denominator 3 in the entire thing. So, what I'll get? 3x square plus 4x minus 4. This is what I get. Right, everyone? Okay. Now, what's the step for splitting the middle term? Px is equals to 0. We'll put px is equals to 0. So, that means we are going to put 3x square plus 4x minus 4 over 3 is equals to 0. Right, everyone? Now, good for you. You can take this denominator on the left hand side and move it, on the right hand side. So, finally, what do you get? You get 3x square plus 4x minus 4 is equals to 0. That's it. Now, you have to basically simplify this or factorize this. Okay? Chalo ji. Now, in the previous question, what was there? I'll just take you to the previous question, guys. Sorry. In the previous question, you could see that the coefficient of x square was 1. The coefficient of x square was 1. That's why we just wrote that a plus b should be coefficient of x and ab is should be equals to constant. Okay? But if the coefficient of x square is not 1, for example, here coefficient of x square is not 1, right? So, in that case, what do? You find again two numbers, a and b. The addition of both the numbers, should be 4 only, this here. But the multiplication of both the numbers should be constant into coefficient of x square. I'll write it here. Constant into coefficient of x square. Coefficient of x square. Got it? I hope you understood the difference here. Since the coefficient of x square was not 1, that's why when you are writing the product of both the numbers, it should be constant into coefficient of x square. That means that a into b should be what? 3 into negative 4. Please don't eat your negative signs. Right? So, negative 12. So, now I need to find out two numbers whose product is negative 12 and addition is 4. Now, product is negative 12, matlab ki one of the number has to be positive, another one has to be negative. Very obvious, right? Now, the addition is positive though. The addition is positive. What does that tell you? That tells you that the larger number should be positive and the smaller number should be negative. Tabhi though, when larger number is positive and smaller number is negative and you add them, you will obviously get addition sign. And if you multiply, you will obviously get negative sign, right? Okay, so now with that, let's start. Let's think about two numbers. One negative, one positive. We have to think about two numbers, one negative, one positive. And the multiplication should be negative 12. So think about this, 6 into negative 2. 6 into negative 2, guys, negative 12. Why did I take 6 positive and 2 as negative? Because remember, larger number should be positive. Then only when you evaluate both of these, you will get a positive answer. When you add both of these, you will get a positive answer, right? So, 6 plus negative 2, 4. Okay? So, what are your numbers, guys? Your numbers are 6 and negative 2. So, what you are going to do? You are going to split 4x as positive of 6x and negative of 2x. So, you are writing 4x as 6x minus 2x. Splitting the middle term. Okay. And minus 4 is equals to 0. Okay, now let's take common in the first two terms. So, we can take 3x common. So, you will get x plus 2 here. And here we can take negative 2 common and inside we'll get x plus 2 is equals to 0. Right? So, now you can see x plus 2 common in both of the terms. So, you will take out x plus 2 everyone. And here you will have 3x minus 2 equals to 0. So, now when the product of two numbers is 0, then individually both of these should be 0. Like one of these should be 0, right? So, you will say that, okay, x plus 2 is equals to 0 means x is equals to negative 2, right? And 3x minus 2 is equals to 0 means x is equals to 2 by 3. So, what are the zeros here, everyone? The zeros are negative 2 comma 2 by 3. That's it. Simple, easy, very basic. right? So yes, I hope you understood this and you have all done splitting the middle term method before. So yes, do revise it अच्छे से, ठीक है? चलिए जी. So with that, let's move on and let's do this problem. So देखो, from zeros of a polynomial, there are two types of questions that can be asked in board exam. One type is simple. You just have to find the zeros of a quadratic polynomial. Another type is that you have a quadratic polynomial. For example, here quadratic polynomial is given. So you have the quadratic polynomial and one of the zeros of the quadratic polynomial is given. You have a quadratic polynomial, one zeros is given, and you have to find the value of a variable that is used in the quadratic equation. For example, here we have the quadratic equation in terms of A. In terms of A, right? This is your quadratic equation in terms of A. Quadratic polynomial. Sorry, guys. Now, one of the zeros is given as -3. Can you see? -3 is one of the zeros, right? You have to find the value of A. This is very common type of problem that has been asked in board exams. So, please pay attention. And it's very easy also. Dekho, we know that if it's given that -3 is the zero of this polynomial, then obviously P of -3 has to be 0. Right? -3 is the 0, so P of -3 will be 0. Now, all you need to do is put in place of x -3. Okay? So, let's do that everyone. A minus 1 -3 square plus A into -3 plus 1. And what is this equals to? This equals to 0 because obviously -3 is the 0 of the polynomial. Okay. Now, let's evaluate it everyone. So, you have 9 A minus 1 minus 3a plus 1 is equals to 0. 9a minus 9 minus 3a plus 1 is equals to 0. So, 6a minus 8 is equals to 0. A is equals to what? 8 over 6, which is 4 over 3. So, what is the value of A, everyone? 4 over 3. Right? Option number C is the correct answer. Everyone that gave the correct answer, pat yourself on the back, guys. Well done. Good job. Okay? So, I hope you understood what you have to do. You just have to plug in the 0 in the polynomial and equate it to 0 and you will get the value of the unknown variable. Very simple. Okay? So, yes, very important. Let's come to geometrical meaning of the zeros of a polynomial. Very, very important topic of the chapter polynomial and very easy, guys. Very easy. Okay? So, yes. See everyone, when we are talking about zeros, what do we mean graphically? Okay, what do we mean graphically? So think about it. Zeros of a polynomial basically is the value of x for which px becomes 0, right? So when you think about it graphically, I have already told you px is denoted by y coordinates and x, obviously x coordinate, right? So wherever px becomes 0, that points would obviously lie on the x-axis, obviously, right? So think about it, if I have the graph of any polynomial px like this, right? So here in this graph, you can clearly see that at these two points, the value of px is what? 0. The value of y coordinates is 0, right? So the value of px is 0. So you can say that here, let's just suppose we have x1, comma 0. The coordinates here is x2, comma 0. So that means that these x1 and x2 are what? They are the zeros of the polynomial. Yes or no? Because here the values of px are becoming 0. Right? So that means graphically you can say that wherever the graph of px intersects the x-axis or touches the x-axis, both of these things are true. Intersects ya touches, okay? So wherever the graph of px touches or intersects the x-axis, there you get the 0 of the polynomial. Right? So that means just by seeing the graph of a polynomial, I'll just erase this. Just by seeing the graph of a polynomial, you can tell the number of zeros of a polynomial. For example, here you have this graph of a polynomial px, right? So it is intersecting the x-axis at 2 points. So these 2 points x coordinates, let's suppose this is x1, this is x2. x1 and x2 would be the zeros of this polynomial and hence there will be 2 zeros of this polynomial. Got it? Similarly here, notice this polynomial's graph is intersecting the x-axis at exactly 3 points. So there are 3 zeros of this polynomial. So to check the number of zeros, all you need to check is where, at how many points is the graph either intersecting the x-axis or touching the x-axis. Okay? Chaliye. So with that, let's just do this problem from your NCERT. Okay, this is the best problem to practice this type, the type of questions asked in board exams. So first of all, we have this graph here. Okay, I'll just highlight it in case you people cannot see it. This is your y coordinate, this is your x coordinate, right? Now here you can see this pink line that is denoting the graph of the polynomial, right? Now this pink line here, is it intersecting the x-axis at any point? No, it's not, right? It will go parallel to x-axis always, right? So here, what you will say about the zeros of px? It has 0 zeros. It has how many zeros? 0 zeros, because there is no point of intersection with x-axis. Got it? Now let's move on to the second graph here. So in the second graph, you can see that there is one point of intersection of this graph with x-axis. Please do not get confused with point of intersection of y-axis. That is of no importance. Okay? So one point of intersection matlab 1 zeros. Simple guys, simple. Here, how many points of intersections are there? 1, 2 and 3. So with x-axis, 3 points of intersection, so 3 zeros. 3 zeros guys. Okay, here in this one you can see that there are 2 points of intersection with the x-axis. This is the graph, right? So you will say 2 zeros. You will say 2 zeros. Here, how many points of intersection with x-axis? 1, 2, 3, 4. 4 zeros. 4 zeros guys. Here, how many points of intersection? So, 1 point of intersection. But here also the graph is touching the x-axis. So, you have to consider the points where the graph is touching x-axis. That is also to be considered, right? Because at these points also the px is becoming 0, right? So, how many points of intersection are touching? 3. So, 3 zeros. Simple, right? So, pat yourself on the back guys if you gave the correct answer. Okay, chalo ji. So with that, now let's discuss about linear polynomial and quadratic polynomial, like how many zeros it can have. And this is very important. So please pay attention because I have a point to make. Okay, I will make that point after making you understand this. So dekho bacha, when you talk about linear polynomials, so on plotting linear polynomials, you will always get a straight line. What you'll get? You'll always get a straight line, right? For example, here you can see y is equals to ax plus b. This is what? This is a straight line, right? Okay, so now linear polynomials graph is a straight line which will always intersect the x-axis at 1 point, right? How many points guys? 1 point, right? So 1 point of intersection, 1 point of intersection means 1 zeros, 1 zeros, right? So for a linear polynomial you will have 1 zeros. Okay, simple. Okay guys, now let's move on to a quadratic polynomial. So for a quadratic polynomial, the graph that you get is very, very interesting because it has a name. Okay, so you get a parabola type of graph. What is a parabola guys? So think about it, you must have done it also. If you throw a stone towards sky, the stone will never go like this and come back like this. It will never do that, okay? What it will do is, it will make a shape like this, like it will attain its maximum height and then come back like this. So this shape here is what? This is parabola. This is what? This is parabola. And I hope you understood why parabolic shapes are pretty important when you see, the launch of missiles and everything. They always take parabolic shapes, right? So yes, parabola is this. This also is a parabola. Okay, this one is this is also parabola, this one's also parabola. So I hope you understood what parabola is. So whenever you have a quadratic polynomial and whenever you plot it, you will always get a parabola. Okay? Now let's see the different kinds of parabolas that we can get. Okay, so these two, first kind would be these two, where the parabolas are intersecting the x-axis at 2 points. Here you can see that the parabolas are intersecting at 2 points. So that means you have 2 zeros, guys, right? You have how many zeros? 2 zeros for the quadratic, polynomial. Okay? Also, one more thing, guys, you can see that here it's written a greater than 0, here it's written a less than 0. What does that mean? So let's understand this. This is also written in NCERT, so it's important. Remember, whenever the leading coefficient a is greater than 0, that means the coefficient of x square is greater than 0, that means it's positive. Whenever a is positive, graph is smiling. Graph is smiling. You can see it's smiling, right? Whenever a is negative, guys, the graph is frowning. Can you see the frown? Can you see the frown? Yeah, see, frown, right? So you can remember it like this. When a is positive, the graph is smiling. It opens upwards. Whenever a is negative, the graph opens downwards. It's frowning. Okay, ji? Okay. So anyways, here you can see that there are 2 zeros because there are 2 points of intersection. But what if a quadratic polynomial has a graph like this or this, whatever? So here you can see that in both the cases, the point of intersection is what? 1. So that means that in this case, there would be one distinct 0. One distinct 0. Yes, everyone? Because there is only one point of intersection. So 1, 0, right? 1, 0. Okay, cool. So we have a quadratic polynomial that can have one distinct 0. Acha, we can also have graphs of polynomial like this, where the graphs are not touching the x-axis at all. Here, you can see that the graph is not touching the x-axis at all. Here also, the graph is not touching the x-axis at all. So that means here, how many zeros? 0 zeros. 0 real zeros. Right? We are talking about the world of real numbers, by the way. So, in the world of real numbers, 0 zeros. Matlab ki bacha, a quadratic polynomial, right, has degree what? It has degree 2. Notice, it has degree 2. Now, it can have either 0 zeros, or it can have 1 zeros, or it can have 2 zeros. Yes or no? So that means, what can we say? Like now we can clearly say that it is not necessary that a quadratic polynomial, that means a polynomial with a degree 2, will have exactly 2 zeros. No. It will have at most 2 zeros. It will have at most 2 zeros. So the relationship between degree of a polynomial and number of zeros is what? That number of zeros would be at most n for a polynomial of degree n. If a polynomial px has degree n, it has what? It has degree n, then that means it will have at most, zyada se zyada, at most n number of zeros. N number of zeros. That means it cannot have more than n number of zeros, but it can have less than n number of zeros. At most, matlab ye hota na, zyada se zyada, right? Okay, this is very important, guys. It's very basic. Okay, but and you do have problems that have come in board exams directly from this concept. So it's very important, right? Let's talk about a cubic polynomial. The cubic polynomial has degree 3. Degree 3. Okay, degree 3. Now, that means what? That means that this polynomial will have at most 3 zeros. At most 3 zeros. Matlab, it can have 0 real zeros, or it can have 1 real zeros, or 2 real zeros, or 3 real zeros. But not more than that, guys. Not more than that. Discuss this problem. The degree of polynomial having zeros -3 and 4 only is. So your polynomial only has -3 and 4 as its zeros, right? So there are no repeated zeros. Got it? So in such scenarios, since there are exactly 2 zeros, so the degree would be what, everyone? Degree would be 2. Okay, what would be the degree? The degree would be 2. So whenever you have problems where it's given, like, the zeros are given like this and this, only word is used. Okay, so then the degree would be equal to the number of zeros. Okay, chali. So with that, let's move on to this assertion reason type question that has been asked in 2024, guys. Let's see. Again, pretty easy, okay? Zeros of a polynomial px is equals to x square minus 2x minus 3 are -1 and 3. This is assertion. Reasoning is saying the graph of polynomial px is equals to x square minus 2x minus 3 intersects the x-axis at negative 1, 0 and 3, 0. So, how do you solve assertion reason type questions? This is the first thing you should know. So, bacha, in assertion reason type question, the first thing you need to do is you have to check the validity of both the statements, whether the statements are even correct individually or not. So, let's start by checking whether the first statement is correct or not, right? So, x square minus 2x minus 3, they are saying that its zeros are negative 1 and 3. So, all you need to do is put P1 and see P1 is coming out to be 0 or not. You can see negative 1, my fault. P of negative 1. See, P of negative 1 is coming out to be 0 or not. In fact, it is coming out to be 0. You can, check. Similarly, put put 3 in the given polynomial and see whether it is coming out to be 0 or not. So, you can see 3 into 3 is 9, 9 minus 3 is 6 and here you will get 6. Yes, it is also coming out to be 0. So, since on plugging negative 1 and 3, the polynomial is becoming 0. So, yes, negative 1 and 3 are the zeros of the given polynomial. So, our assertion statement in itself is true. The statement is true. Okay. Now, let's go to the reasoning part. The reasoning part is saying that the graph of polynomial, the same polynomial, will intersect x-axis at negative 1, 0 and 3, 0. So, whatever this polynomial, graph's polynomial would be, it will intersect the x-axis at first of all 2 points because there are 2 zeros and it's a quadratic polynomial, right? So, it will intersect the x-axis at 2 points, right? Now, at both the 2 points, the value of y coordinate would be 0. That means px would be 0. Value of y coordinate would be 0. What would be the value of x coordinate? 0. Not 0, the zeros here. For example, at x is equals to negative 1, y is becoming 0 or px is becoming 0, right? So, at x is equals to negative 1, px is becoming 0. At x is equals to 3, px is becoming 0. Sorry, I'll just draw this again, my fault. Negative 1 will come here, na? So, for when x is negative 1, this is becoming 0. When x is 3, it's becoming 0. Simple. So, yes, this is true. This is obvious. Like, this is the definition, geometrical meaning of the zeros of a polynomial. Right? For the zeros of a polynomial, the x coordinate would be the value of x and y coordinate would be 0. So, yes, reasoning is also true. And reasoning is like whatever your assertion is, whatever the first statement is, the second statement is giving the correct reasoning. Right? If that means that since negative 1 and 3 are the zeros of the polynomial, so the graph of this polynomial will intersect the x-axis at 2 points and the coordinate of both the points would be what? Negative 1, 0, 3, 0. So that means both assertion A and reason R are true and reason R is the correct explanation of the assertion A. Okay, so remember in AR type question, first check the validity of both the statements individually. Then after that, check whether the second statement is explaining the first statement or not. Got it? If it is explaining the first statement, then the first option is correct. Okay, chaliye. So with that, let's move on to this next problem, everyone. Again, assertion reason type problem asked in 2024 again. Okay, if the graph of a polynomial touches x-axis at only one point, then the polynomial cannot be a quadratic polynomial. Okay, a polynomial of degree n, where n is greater than 1, can have at most n zeros. Now, bacha, first of all, you will check the validity of both the statements individually. So, let's start with the first one. They are saying that the graph of a polynomial is touching x-axis at only one point. And they are saying that if that happens, then the polynomial cannot be a quadratic polynomial. But we just saw a graph like this. This here is a graph of a quadratic polynomial, right? Ax square plus bx plus c, where a is greater than 0. Okay, this here is the graph of a quadratic polynomial because it's parabola and it is touching the x-axis at exactly one point. So how are they saying that if polynomial touches x-axis at one point, it cannot be a quadratic polynomial? It is a quadratic polynomial. Come on, here we saw this, right? So they are correctly incorrect. The first statement is clearly false. Okay, so again I repeat, test the validity of both the statements individually. Now let's move on to the second statement, guys. Second statement is saying that a polynomial of degree n where n is greater than 1 will have at most n zeros. This is something we have already studied, right? I have already explained that if for a polynomial the degree is n, it will have at most n zeros. Where n is greater than 1, why? Because for n is equals to 1, the equality holds. Whenever n is equals to 1, that means whenever you have a linear polynomial, then the number of zeros would always be exactly 1, not at most 1, exactly 1. Okay, I'll write it here. When degree n is equals to 1, you get what? You get a linear polynomial, right? And for a linear polynomial, always 1 0. Always 1 0. Why always 1 0, guys? Ask yourself this. Think about it now. You always get a line, right? And this line will pakka intersect x-axis. Okay? Chalo. And the line, why will the line always intersect x-axis? Because linear polynomial standard form is ax plus b, where a cannot be 0. That's why, guys. That's why. Think about it. Okay? So that's why n is greater than 1 they have used. And this is true. The second statement clearly is true. So that means assertion A is false, but reason R is true. And reasoning wale first two statements, first two options are totally incorrect, clearly. Okay, now here assertion A is false, but reason R is true. This is the only thing that is true here. So whenever either one of the statement becomes false, then first two options though would never be correct. You will only have to check for the last two options. Okay? Chalo. So yes, option number D is the correct answer, and everyone that gave the correct answer, kya bata, well done, guys. Pat yourself on the back. Good job. Chalo. So with that, let's move on, guys, to the last but the most important topic of this entire chapter. Most of the questions are asked from this topic, and this topic has only these two concepts, these two formulas basically. Okay, relationship between zeros and the coefficients of a quadratic polynomial. Cubic polynomial wala relationship is not in your syllabus, got it? Okay, so if you have a polynomial whose standard form is ax square plus bx plus c, and a is not equals to 0, obviously, because you're talking about a quadratic polynomial, then the sum of zeros, where we are saying that alpha and beta are the zeros. Alpha and beta are the zeros of the polynomial. Okay, so here, if alpha and beta are the zeros of the quadratic polynomial, then the sum of zeros, that means alpha plus beta, will always be equals to minus b by a. That means minus of coefficient of x divided by coefficient of x square, right? And alpha into beta would be equals to c by a. That means constant term divided by coefficient of x square. See, people, you will have to mark this up. Okay, and this is one of those things that you should do, right? Because it will give you easy marks in your board exams. Okay, so alpha plus beta minus b by a, alpha into beta c by a. Okay, remember this. Now another thing, before that, let's just practice this problem, and then we'll come to the one more type of problems that are that is asked in board exams based on the same thing. Okay, chalo. Anyways, okay, let's do this question here, everyone. If alpha and beta are the zeros of polynomial, what is the polynomial, everyone? Let's write the polynomial. Px is equals to 3x square plus 6x plus k. Right? So you have an unknown quantity here. Okay. Such that alpha plus alpha beta is equals to negative 2 by 3, where what is alpha and beta? Alpha and beta are the zeros of this polynomial. Then the value of k is, you have to find the value of k. Okay. Now everyone, we do not know the zeros of the polynomial. Okay? We just know a relationship between the zeros of the polynomial. What is that relationship, guys? Let's write that down. The relationship is like this: alpha plus beta plus alpha beta. I have put brackets here. Why did I put brackets here? Because I wanted to highlight how we can use the relationship between coefficients and zeros of a quadratic polynomial. See, I need to find the value of k, right? Now I know that I can express alpha plus beta as minus b by a. Yes, alpha plus beta is what? Minus b by a. Plus alpha into beta is what? C by a is equals to negative 2 by 3. And what do we have? We have the value of A. We have the value of B. We do not know the value of C. So here in this equation, we have the value of B, A, and we need to find the value of C. We can easily do that, right? So minus B, that means minus 6 over 3 everyone, plus C by A, that means K over 3 is equals to what? Minus 2 by 3. Right? You can cancel 3 from all the sides because on left hand side also 3 is there, on right hand side also 3 is there. So finally you will get minus 6 plus k is equals to minus 2. From here you get k is equals to 6 minus 2, which is equals to 4. So k is equals to what everyone? 4. So the correct answer is option number D. And everyone that gave the correct answer, kya baat hai, well done, good job guys. This was a question asked in 2025. So pretty important, but a pretty easy question guys. Pretty easy, right? 4. Now if you want to check or verify your answer, you can always check alpha plus alpha beta is coming out to be negative 2 by 3 or not. Okay, so you can plug the value of k as 4 and then figure out alpha plus beta and verify your answer also. Okay, chale. So with that, let's move on to this next problem. For what value of k, the product of zeros of the polynomial kx square minus 4x minus 7 is 2. Okay, again, a question directly based on the relationship that we have studied. Let's suppose that alpha comma beta are the zeros of polynomial px, right? Now, they are saying that the product of zeros, that means alpha into beta, is equals to 2. They are saying alpha into beta should be 2. For what value of k? For what value of k would this be true? We know the value of alpha into beta in terms of coefficients, right? What is it? It's c by a. C by a. So we just have to figure out that c by a should be 2. Now here we know that a is not given to us, b is negative 4 and c is negative 7. I'll write it here. A is k everyone, b is equals to negative 4 and c is equals to negative 7. Please remember the negative sign because this is where most of the people lose marks. Okay, so yes, please remember your signs. Now c, the value of c is minus 7. The value of a we don't know, so k is equals to 2. So from here k comes out to be negative 7 by 2. How easy was that everyone? Negative 7 by 2 is the answer. Option number B is the answer. Was it hard? No, right? So come on guys, matlab I think that relationship wale questions are one of the easiest questions, right? So yes, this is it. Again, question from 2024. Okay, now let's see another type of. So how do you do this problem? So first of all, let's see what P is and how we can find it, right? So P basically here, let's say that A is equals to 1, right? B is equals to P and C is equals to Q, right everyone? Now we can clearly say that P over 1 would be equal to sum of zeros of the polynomial. Yes or no everyone? Right, sum of zeros. Okay. So we basically have to find the sum of zeros of this polynomial, but clearly we cannot find that out because nothing is given. Now it's given that the zeros of this polynomial here are twice the zeros of this polynomial here. Now that would be very helpful because what if I take the polynomial 5x square minus 5x minus 6 and its zeros are alpha comma beta. If its zeros are alpha comma beta, then automatically the zeros of this polynomial zeros, it would be what everyone? Twice of alpha comma twice of beta. Do you agree? Yes or no? Right. Now, I can figure out alpha plus beta from here very easily. It is what? Minus b by a, that would be 5 by 4. right? Now, I can easily figure out twice of alpha plus twice of beta from here because it would not be nothing but twice of alpha plus beta, right? So that would be equals to twice of 5 by 4. So that would be 5 over 2. Yes, everyone? Simple? Okay. Now, notice that the sum of zeros for this polynomial here would be what? Twice of alpha plus beta. So, from here I can say that, okay, here we'll have minus. I forgot minus sign. Minus of p would be equals to twice of alpha plus beta, which would be equals to 5 by 2. So, p is equals to minus 5 over 2. That's your answer. Minus 5 over 2. Option number A is the correct answer, guys. Simple, basic, right? Okay, chalo. Let's move on to this problem here. The zeros of the quadratic polynomial x square plus 99x plus 127 are. Now, in the options, you can clearly see that all we need to find out is the signs of the zeros, not the exact value, right? So, how can you find the signs? Again, let's use relationship wala concept, right? So, first of all, let's just suppose that alpha and beta are the zeros of this polynomial. So, alpha plus beta would be equals to minus b by a, right? That would be minus of 99. And alpha into beta would be equals to c by a, that would be equals to 127. Right? I'll write it here. If you people get confused, b is equals to minus 99, c is equals to 127. Okay. Now everyone, first of all, let's see the product. The product is positive. What does that tell you? That tells you that either both alpha and beta are positive or both alpha and beta are negative, right? These are the only two scenarios. But alpha plus beta is a negative. That tells us that one of the zero has to be negative, because when you add two positive numbers, you will never get a negative result, right? So one of the number has to be negative. So that means both positive is something that cannot be true. From here, only this part would be true, that is both of them are negative. When both of them are negative, their sum is negative and the product is positive, right? So what is the correct answer, everyone? The correct answer is option number A. Both of them are negative, right? Yes. Let's move on then. Okay. Alpha and beta are the zeros of the polynomial 6x square minus 5x minus 4. Then 1 by alpha plus 1 by beta is, okay, a very common type of problem, guys, in your board exams. Okay. So let's see. So first of all, notice 1 by alpha plus 1 by beta. What would that be? Let's simplify. So I'll make the denominator same. How can I do that? I'll just multiply the denominators. So alpha, beta. So now I'll have to multiply beta here. I'll have to multiply beta here also. Here I'll have to multiply alpha. Here also alpha. Right? So basically what do I get? I get beta plus alpha. Or basically you can say that 1 over alpha plus 1 over beta is equals to alpha plus beta over alpha beta. Now I know alpha plus beta is equals to minus b by a, and I know alpha beta is equals to c by a. A and a will get cancelled, so this becomes minus b by c. This is important, which you can remember, or you can even derive, like it hardly takes 1 minute, right? So 1 by alpha plus 1 by beta would always be equals to minus b by c, right? So minus b by c, everyone, which would be equal to what? So here a is 6, b is equals to minus 5 and c is equals to minus 4. So minus of b would be 5 and c would be minus 4. So, minus 5 by 4 is the correct answer. Minus 5 by 4, everyone. Option number B is the correct answer. Simple. Right? So, please remember this. Very easy. Okay. So, yes, with that, let's move on. If alpha and beta are the zeros of the quadratic polynomial, px is equals to x square minus bracket k plus 6 bracket close x plus twice of 2k minus 1, then the value of k, if alpha plus beta is equals to half of alpha beta. Okay. So, again, whenever you see such type of things, you should always think that, okay, this must be a question of relationship of coefficients and zeros, right? Now, I know alpha plus beta. I know alpha plus beta is minus b by a, right? and I know alpha into beta. Alpha into beta is equals to c by a. So minus b by a is equals to half c by a. Right, everyone? Okay. Now you can cancel a on both the sides and you will get minus b is equals to c by 2. Right? Minus b is equals to c by 2. So this is something we derived directly from here. Okay, now let's plug in all the values from here. So minus b, everyone. See, first of all, a is equals to 1. B is equals to minus of k plus 6 in the bracket. And c is equals to twice of 2k minus 1. Now I need to figure out the value of k. I have a relationship here or an equation here through which I can figure out the value of k, right? So let's plug everything here. Minus of b, that would be k plus 6. C by 2, everyone. So that would be twice of 2k minus 1 over 2. 2 and 2 gets cancelled. We have k plus 6 is equals to 2k minus 1. From here, you can say that k is equals to 7. So what's the correct answer, everyone? Option number B is the correct answer. Easy, easy, lemon squeezy, right? I can see all of you people getting, the entire 4 or 6 marks, whatever marks come, from Polynomials chapter, whatever marks come in exam. I see you people getting the entire marks, okay? Okay. If 1 0 of the polynomial px is equals to 6x square plus 37x minus k minus 2 is the reciprocal of the other. So they are saying that for this polynomial, 1 0 is the reciprocal of another 0. Okay, that means if 1 0 is 2, then the other 0 has to be 1 by 2. That means if 1 0 is alpha, the another 0 has to be 1 by alpha. Right? Okay. So what we'll do? We'll write let the zeros be alpha, comma 1 by alpha. Right? Now we have to do what? We have to figure out the value of this k. Okay. Now let us be clever. Think about it, guys. We don't know the value of, alpha or beta, and we have to figure out the value of k, which is actually coming, in the value of c, right? So here a is equals to 6, b is equals to 37, and c is equals to minus of k minus 2. Right, everyone? Okay. Now, if I use product of zeros, wala thing, product of zeros. So notice that product of zeros for this would be what? Alpha into 1 by alpha, which would be 1. How interesting. That simply means that c by a should be equals to 1. That simply means that minus of k minus 2 over 6. This is 6, guys. Over 6 has to be 1. Now, can you not solve this linear equation? You can, right? So, from here we can say that minus of k plus 2 is equals to 6. So, k is equals to minus of 4. See, what did we learn from this problem? The main thing to learn is whenever 1 0 of a quadratic polynomial is the reciprocal of another, right? Then product of zeros would always be 1. Product of 0 would always be 1. That means c by a would always be 1. C by a would always be 1. Okay? Always in such type of problems. That's it. That's what you had to use here. Okay? So I think this was very simple. With that, let's move on. Okay. Now, if alpha and beta are the zeros of the polynomial fx is equals to x square minus 4x minus 5, then find the value of alpha square plus beta square. This is very interesting, guys, and in this question we use identities that you have studied in 9th grade or even in previous 8th, 7th grade also, right? So first of all, let's talk about alpha square and beta square. Let's talk about this. Alpha square plus beta square, everyone. How can I figure out the value of alpha square plus beta square? I know the value of alpha plus beta. I can figure that out using the relationship wala concept. But how can we figure this out? So, bacha, dekho. Alpha square plus beta square is always equals to alpha plus beta whole square minus 2 alpha beta. You want to ask how? Open this up. If you want to ask how, you can open this up or we can see it here also. See. alpha plus beta whole square is equals to what, everyone? Alpha square plus beta square plus 2 alpha beta. I hope you remember this identity, right? So from here, can you not figure out alpha square plus beta square? What would that be? It would be, see, you will just take this 2 alpha beta on the other side. So alpha plus beta whole square minus 2 alpha beta. See, directly. So I wrote this directly here. You can do this also. Totally your choice, guys. Totally your choice. I'll just write this thoda sa or coherently. Yeah. Alpha square plus beta square is equals to alpha plus beta whole square minus 2 alpha beta. Cool, everyone? So now, let's see here. You have to figure out alpha square plus beta square. Now, if you figure this out, you will have this. Can you figure this out? Very easily, because you know alpha plus beta, right? It would be sum of zeros and you know the relationship. You know alpha beta, right? So let's write everything down. Alpha plus beta would be minus b by a whole square minus 2 c by a, because alpha into beta is c by a, right? Now here a is equals to 1. Can you see in the polynomial a is 1? B is equals to minus 4, everyone, and c is equals to minus 5. Plug everything here, right? So what do you get? You get alpha square plus beta square is equals to, let's take this bracket here. So 4 over 1 square minus 2, c is minus 5 over 1, right? Okay, so this will come out to be 16 plus 10. That would be equals to 26. So yes, alpha square plus beta square, everyone, is equals to what? It is equals to 26. Did you understand this? I hope you did. It's very basic, right? We only used identity here. Okay? Chalo. Now, let me take another slide and I'll take the same question. X square minus 4x minus 5. X square minus 4x minus 5. Now, what if, guys? What if I ask you the value of alpha square minus beta square? What if this is asked? How will you figure that out? Let's see. Okay? Chalo. So, to figure out alpha square minus beta square, let's see. What I can do is, I know that alpha square minus beta square is equals to alpha plus beta into alpha minus beta. Now, I know the value of alpha plus beta. That's very easy to figure out from the given polynomial. But alpha minus beta, how would I figure that out? So now the question has changed to what? The question has changed to figuring out alpha minus beta. How will you figure this out? Alpha minus beta. How will you figure that out? Let's see. This is very easy, okay? And it's very interesting also. Okay. So for alpha minus beta, everyone, again, use alpha minus beta whole square identity. What do you get? Alpha square plus beta square plus 2 alpha beta. Minus 2 alpha beta. My fault, guys. My fault. Minus 2 alpha beta. Right, everyone? Okay. Now, everyone, all you need to do is think that can you figure out alpha square plus beta square? You can. We just saw that alpha square plus beta square is actually equals to alpha plus beta whole square minus 2 alpha beta. Right or not? And then you had another negative 2 alpha beta here. So from here you can say that, okay, alpha plus beta square minus 4 alpha beta. This would give you alpha minus beta whole square. Alpha minus beta whole square is alpha plus beta whole square minus 4 alpha beta. So if you have to find alpha minus beta, people, you will just take the square root of alpha plus beta whole square minus 4 alpha beta. Looks tricky, but it is not if you know your identities. That's it. You should know your identities, guys. Got it? So if alpha square minus beta square is asked, you have to figure out alpha minus beta first. Okay? Because you can use this identity, but for this identity, you need alpha minus beta. To figure out alpha minus beta, use the identity alpha minus beta whole square. There, plug in the value of alpha square plus beta square. So you will figure out alpha square plus beta square first. Okay? You can figure it out by using this, right? Or you can directly apply this to figure out alpha minus beta, whatever you want to do. right? Similarly, you can figure out alpha cube plus beta cube. Can you do that, everyone? You know the identity of a cube plus b cube, I hope. What is the identity? I'll write it here. Wait. Alpha cube plus beta cube. Alpha cube plus beta cube is equals to alpha plus beta here, alpha square plus beta square minus alpha beta. Right, everyone? Now you can figure out alpha plus beta very easily if the polynomial is given. The main thing is figuring out alpha square plus beta square. But you already know how to figure out alpha square plus beta square. Don't you? You can use this here. That's it. So the main thing is remembering how to figure out alpha square plus beta square, but because that is used in a lot of these questions, right? So you can use that. Similarly, alpha cube minus beta cube, everyone, you can figure it out, right? Okay. How can you figure it out? Alpha minus beta, alpha square minus beta square, sorry, plus beta square plus alpha beta. So now alpha square plus beta square, again you can figure it out, alpha beta, so you already know, right? So yes, these are certain types of questions that can be asked in your board exams, though the probability is less. Alpha square plus beta square is something that can be asked, its probability is high. But alpha cube plus beta cube or alpha cube minus beta cube or even alpha minus beta, the probability is low, but still guys, you know, from what I've seen from 2025 paper, anything can be asked, right? So yes, please prepare yourselves. Okay, now let's move on to the next part. See, relationship between zeros and coefficients of a quadratic polynomial. So from this we have one varieties of question that we have discussed. Now the second type of question that is also very common is where you have to find a quadratic polynomial. Okay, so remember guys, whenever sum of zeros is given to you and product of zeros is given to you, then how can you find the quadratic polynomial? So the quadratic polynomial would be nothing but any constant k multiplied with x square minus alpha plus beta x plus alpha beta. That means you can write it like this: k x square minus sum of zeros into x plus product of zeros. You will understand this more when we are doing problems, okay? So don't worry about it. We'll do problems and you'll understand it more, right? Why do we put k? That also we'll understand when we are doing problems. But for now, you know, mug it up, okay? Chalo, let's do problems based on this directly. Find a quadratic polynomial whose sum and product of zeros are 0 and negative 9. So sum of zeros, guys, is given to you as 0, good for us, and product of zeros is given to us as negative of 9. 2025 question, okay? So this question is important. Now we have to find the quadratic polynomial. We just studied how to find quadratic polynomial. So what would be the quadratic polynomial? It would be k multiplied with x square minus sum of zeros, which is 0x, plus product of zeros, which is negative 9. Yes, everyone? So this would come out to be k x square minus 9. This is our polynomial, right? Now here k can take any value, guys. You can take k as 1 or 2 or 3 or 4 or 5 or 1 by 2 or 6 by 8 or negative 100, anything, right? So that means that the polynomials whose sum of zeros is 0 and product of zeros is negative 9 is not unique. There are infinite such polynomials which can have sum of zeros as 0 and product of zeros as negative 9. Do you understand? That's why we put k here, because this k denotes that we can multiply this part here with any constant and we'll keep getting polynomials that satisfy both of these. Understood? So there are infinite such polynomials that will have sum of zeros as zeros and product of zeros as negative 9. Now, second part of the question, please don't miss the second part of the question. They are asking us to find the zeros of the polynomial so obtained. So we have to find the zeros of x square, k x square minus 9. I think that's pretty easy, guys. Can you not figure it out? So let's just factorize it. X square minus 9. So a square minus b square. A minus b, a plus b, right? So let me write this down. X square minus 3 square, right? So we can factorize it as k x minus 3, x plus 3, right? Now let's just put px is equals to 0. So if I put px is equals to 0, I'll get x minus 3 is equals to 0 or x plus 3 is equals to 0. So from here we can say that the zeros are what? Plus minus 3. Right? Now you will say, ma'am, what happened with k? So we took k on the other end side and it became 0. That's it. So the zeros of the given polynomial are what? Plus and minus 3. Now you can verify also, guys. You can verify whether the polynomial that you formed is the correct one or not. Because sum of zeros, plus 3 minus 3 is 0. Product of 0, positive 3 into minus 3, negative 9. Done deal? So you can also verify your answer like this, right? So remember, there is another type of question that is asked, but it is similar to this only. There you have to find the quadratic polynomial when sum of zeros and product of zeros is given, and you have to verify the relationship of the zeros and the coefficients. Okay? So to verify the relationship between zeros and coefficients, you will first have to find the zeros of the polynomial, right? For example, here we found the zeros of the polynomial. And then you will show that, okay, the sum of zeros is actually 0 and the product of zeros is whatever is given. Okay? So in those questions, remember to find the zeros after you have found the quadratic polynomial. Anyways, let's move on, guys, and discuss this problem here. Find a quadratic polynomial whose zeros are reciprocals of the zeros of polynomial fx is equals to ax square plus bx plus c, where a is not equals to 0 and c also is not equals to 0. A 3-marker question and a good one at that. Okay, so let's see how to do this. First of all, everyone, let's suppose that alpha comma beta are the zeros of ax square plus bx plus c, where a is not equals to 0 and c also is not equals to 0. They have given to us. I have written it down. You don't need to though. Okay, so alpha and beta are the zeros of ax square plus bx plus c. Cool, everyone? Got it? Now we have to find a polynomial whose zeros are reciprocals of the given zeros. So that means let 1 by alpha comma 1 by beta be the zeros of the new polynomial we have to find. Let's suppose the new polynomial that we have to find is qx. So we have to find qx, everyone. Okay, and the zeros of qx are what? Reciprocal of the zeros of this. So I assume that the alpha and beta are the zeros of this polynomial. Now qx is the polynomial which we have to find, and its zeros are reciprocal of the zeros here. So 1 by alpha and 1 by beta. ठीक है? Okay. So now qx would be equals to what, everyone? Let's pay attention. Qx would be equals to k x square minus sum of zeros plus let's multiply x also, obviously, x plus product of zeros, right? Okay, everyone. Now let's plug in everything. So what we'll have k is equals k into x square minus sum of zeros would be what? So we know that the zeros of this are 1 by alpha and 1 by beta. So 1 by alpha plus 1 by beta x plus product of zeros would be 1 by alpha into 1 by beta. Right, everyone? I hope this makes sense. Okay. Now, everyone, let's simplify. So k into x square minus. Now here what we'll do is we'll make the denominator same, and I think we have done this before, so I hope everyone will remember 1 by alpha plus 1 by beta is alpha plus beta over alpha beta. Right, everyone? X plus 1 over alpha beta. Okay. Now, good for you people, you know the value of alpha plus beta. How do you know the value of alpha plus beta? Because alpha and beta are the zeros of this polynomial, right? So I'll take another slide here. Ax square plus bx plus c. This was the polynomial whose zeros were alpha and beta, right? So from here you can say that, okay, alpha plus beta is equals to minus b by a, right? And alpha beta is equals to C by A. Yes or no, everyone? Okay, you can see here. See? Okay. Now, we have to figure out what? We have to figure out Qx. So, Qx is equals to K x square minus alpha plus beta. I'll just rewrite this here so there's no confusion. X plus 1 by alpha beta. Right, everyone? Okay. So, now plug in all the values here. So, Qx would come out to be what? It would come out to be K x square minus alpha plus beta is minus b by a and alpha beta is c by a. Right? And here x plus 1 over alpha beta is what? C by a. Okay? Now, let's simplify this, everyone. So, Qx is equals to K x square. A and A gets cancelled. So, we have minus B by C x plus A by C. Right? Okay. 1 over C by A is A by C. Now, we can also further simplify this. So, this will become K C x square minus Bx plus A. Right? C will go outside. So, yes, you can leave it at that, or you can take K by C as K dash, totally your choice. Or you can leave it here also, you can leave it here also, totally your choice, guys. That's it. That was all you had to do here. So, the number of steps might be a little bit more, but I think the concept was very easy, right? Okay. Chalo ji. So, yes, with that, let's move on to the next problem. If alpha and beta are the zeros of the polynomial fx is equals to 2x square minus 5x plus 1, then find the polynomial whose zeros are alpha plus 1 by beta and beta plus 1 by alpha. So, this time I have to find a polynomial qx whose zeros are this and this. So, qx would look like what? First of all, let's figure that out. Qx will look like what? So, qx would be k, then bracket x square minus sum of zeros, everyone. So, sum of zeros, can I write directly sum of zeros? Sum of zeros would be alpha plus 1 by beta is 1 0 and beta plus 1 by alpha is another 0, right? So, sum of zeros multiplied with x plus product of zeros. Product of zeros would be what? Alpha plus 1 by beta into beta plus 1 by alpha. Right, everyone? This is what your polynomial will look like. I have just used the formula that we have, mugged up. Okay. Now, everyone, we just have to simplify this. What we have to do? We have to simplify this, right? So, let's simplify k x square minus, here, I can just open up the bracket. So, alpha plus beta I'll plug together. And here we have 1 by alpha plus 1 by beta I'll plug together. Right, everyone? X plus. Now, let's multiply all of these together. Okay? So, what we will get, everyone? We'll get alpha into beta. So, alpha beta plus alpha into 1 by alpha, 1. Plus 1 by beta into beta, 1. Plus 1 by beta into 1 by alpha, 1 over alpha beta. Now, don't you know the value of alpha plus beta and 1 by alpha plus 1 by beta? You know, right? If you don't, I'll write it here for you people. See, the polynomial fx is given whose zeros are alpha and a and b. Sorry. It should be alpha and beta, everyone. So, this is alpha, this is beta. Okay. So, yes. So, alpha and beta are the zeros of this polynomial, right? So, from here, I can easily figure out that, okay, alpha plus beta would be equals to 5 by 2 minus b by a, right? And alpha beta would be equals to 1 by 2. Yes, everyone? And 1 by alpha plus 1 by beta, we have done it multiple times. So, I hope you now remember 1 by alpha plus 1 by beta would be equals to minus b by c, right? So, minus b by c would be 5 over 1. Now, plug everything here. That's it, guys. That's it, right? So, let's plug everything here and see what we are getting. Yes. So, k x square minus alpha plus beta 5 by 2 plus 1 by alpha plus 1 by beta 5. This is x, okay, plus alpha beta is 1 by 2. So yes, 1 by 2 plus 1 is 2 plus 1 over alpha beta would be equals to what? 2. Okay. Sorry. That's it. Let's simplify. Okay. So you'll get what? K x square minus 5 by 2 plus 5 everyone. So 15 over 2 x plus 9 by 2. Right? Okay. That's it. That's the answer. That's what we were looking for. Simple? Easy? I think these questions are the questions where you might need to practice 3-4 questions more, right? So no worries about that, everyone. We have got practice sheets for you. But for that, you'll have to go to the link in the description box. Remember, I told you in the beginning of the session, right? So practice problems in the practice sheets, you'll get such type of problems from there, right? So yes, you will have to practice some problems to become good at it. Okay, so yes, with that, let's move on and do the last question of this session, which is a case study based question. So after COVID, not many case studies have come from the chapter polynomial, but still this was a case study that was asked after COVID. So anything can happen. So you should prepare for certain case study questions, right? You should practice some case study questions. Okay, chaliye. So Kriti throws a ball upwards from a rooftop which is 8 meters high from ground level. Okay, first of all, guys, first things first. Let's understand by making a diagram, because this question calls for a diagram. Okay, so Sukriti is doing what, everyone? She is throwing a ball from a rooftop. Let's say this is the rooftop and the length, its height is 8 meters. Okay, now I have already told you that when anything is thrown, it never goes straight up and then straight down. It always follows a parabolic path, right? So if the ball is thrown from here, it will go up and then it will come down. It will form a parabola. Okay? Chalo. So now the ball reaches to some maximum height. So this is the maximum height that the ball is reaching. We do not know what this is. And then returns and hits the ground. You can see it is hitting the ground here. Right? Okay. Let me just... Right. So this is x. At x, the ball is reaching its maximum height. Okay. Now, if height of the ball at time t in second is represented by hm, so they are representing the height of the ball at any time t. Okay, by this graph, by this quadratic polynomial here. That means that h is equals to minus t square plus 2t plus 8 is doing what? It is representing the graph of the parabola here. This here is representing this graph here, right? Where x, this shouldn't be x, I'll rewrite this. This here is t, okay? Where on x coordinates we have time t, so this is basically t. And here we have the height. Okay, so instead of x and y, we are using t and h. T denotes time and h denotes height. Okay. Now, based on this above information, we have to answer questions. ठीक है जी. So I hope this was clear to all of you people, right? Chalo. So with that, let us start with the problems. The maximum height achieved by ball. Okay, first of all, what was the let's write this down. Minus t square plus 2t plus 8. Minus t square plus 2t plus 8. This is, our, this is the polynomial r. This is our polynomial represented by ht. Okay, now maximum height attained by the ball, guys. This probably is the trickiest question of this case study, okay? Because this requires common sense. Now, first of all, you should think about this like this, that the ball was already thrown from a height of 8 meters in upwards direction. So, clearly, the maximum height cannot be 7 or even 8. It cannot be this. Neither 7 nor 8. Right? Okay? Common sense. the height has to be more than 8. Okay, now next everyone. So now let's use some common sense again and think that when time is 0, the height is 8. Yes or no? When time is 0, Sukriti has not thrown the ball yet. So the ball is resting at a distance of 8 meters from the ground. Right? So this, okay. Now what if t becomes 1? If t becomes 1, what is height? How can you figure that out, everyone? Put t 1 here and see what you're getting, right? So let's put, I'll just write it like this. This would be more helpful. H1. So H1 would be what, everyone? H1 would be minus 1 square plus 2 into 1 plus 8. So that would come out to be what? 9 meters. So that means I'll draw the rough diagram here, that here time was 0, right? And height was 8. Now, when time is 1 minute, okay, then the height achieved is 9 meter. Height achieved is 9 meter. Okay, I hope this is clear to everyone. Okay, now what about height when time is 2? Okay, when time is 2 minutes, what about height? I'm just seeing the path it is following. So again, I'll figure out H2. So as soon as I figure out H2, I realize that, okay, H2 would be equals to minus of 4 plus 4 plus 8. So it would be 8. Yes, everyone? 4, yes, 8 meters. Okay, that means that when the time is 2 minutes, the height of the ball has come to 8 meters again. Yes or no? So that means that the maximum height that the ball achieved was at 1 minute. And what was the height? The height was 9 meters. Right, everyone? So here what did we do? We just used some common sense. We just figured out T0, which was already known to us as 8. Then T equals to 1. For T equals to 1, the height became 9. For T is equals to 2, height again became 8. That means that the maximum was attained at 1 minute, and the maximum height was 9 meters. This is the correct answer, everyone. What is the correct answer? Option number C. Everyone that gave option number C as the correct answer, good job, well done. Okay. Now, this here is sort of a hit and trial method, because guys, the actual concept needed to do this problem, that is not there in the syllabus. Okay. So yes, we you could have used common sense. And with that, let's move on. Okay. The polynomial represented by above graph. Come on, guys. Quadratic polynomial, obviously, right? The graph is parabolic in nature, and obviously its polynomial is given to us. Highest power is 2, so obviously it's a quadratic polynomial. So option number B is the correct answer, quadratic polynomial. Okay. Next question. Time taken by ball to reach maximum height. Now we have already seen that the maximum height was 9 meters and it was reached at t is equals to 1 second. Guys, I'm so sorry. I was saying the unit in minutes. My fault. The unit is given in seconds. My fault. So t is equals to 1 second. At 1 second, maximum height of 9 meter was achieved. We have already seen that, right? And again, I repeat, sorry for the wrong unit that I said earlier. Okay, it's second. Okay, so what's the correct answer, everyone? The correct answer is 1 second. Here, this is the correct answer. Okay, next question. Number of zeros of the polynomial whose graph is given. So we have the polynomial given to us is this, minus t square plus 2t plus 8. This was the polynomial, right? Let me just recheck. Minus t square plus 2t plus 8. Yes. So this is our quadratic polynomial. We have to find the number of zeros. So let's just split the middle term and find the number of zeros, right? So here this is ht. Okay. So now let's split the middle term. So think about it. Two numbers which on adding give you 2 and on multiplying give you 8. What are those numbers? On multiplying give you minus 8, because AB should be equals to the constant multiplied with coefficient of the square term, right? So A plus B should be equals to 2 and A into B should be equals to 8 into minus 1. So such two numbers are what? 4, negative 2. 4 into negative 2, negative 8. And 4 plus minus 2, 2. right? So I am going to break it down like this. Minus t square plus 4t minus 2t plus 8. Okay, everyone. So this will become what? Minus, let's just take a common here. So I'll take minus t common. So inside I have t minus 4, and here I'll take minus 2 common. So I'll have t minus 4 common here, right? So this will become minus t minus 2 and t minus 4. So this will become what? So the zeros, I'll directly write the zeros, everyone. The zeros would come out to be 4, t is equals to 4, and t is equals to minus 2. So how many zeros does this polynomial have? Exactly 2 zeros, 4 comma negative 2. So what's the correct answer, everyone? The correct answer is option number B, that is 2. Okay. Next question. Zeros of the polynomial are. Okay, so for the same polynomial, zeros are being asked. We have already figured out zeros, right? We have figured out that the zeros are what? Negative 2 comma 4, right? So option number B is the correct answer. Okay. Chalo. So yes, that is all, I think. This question here is your homework, everyone, because obviously you need to practice some questions yourselves also. So I would love it if you would, answer the this homework here in the comment box. Okay. So yes, with that, I hope you loved this session, guys, and I hope you people are, practicing questions by yourselves also. And please remember to click in the link in the description box below, and you'll get the notes and you'll get all the questions that you can practice from this chapter. So yes, that's it for today, everyone. We'll meet again in the next one short session. Till then, keep preparing, keep practicing. Remember, it's not too late. You can still start from scratch and get the desired marks that you want. So carpe diem, everyone. Seize the day. Bye bye. Thank you.